Okay, and so today we're going to look at probability and set theory. And so to make sure that we're on top of it, we want to make sure that we go back over our notation from set theory and our symbols, that we're well aware of our Venn diagrams. And so as part of that, we're just going to take a little quick look here at some of our diagrams. So here we have just one set and then the complement of it. And that basically represents as well what we all know, that all our probabilities must add up to 1. Okay? So all our probabilities, the maximum probability that we can have is 1. Now, when we disjoint sets, it means that nothing crosses over between them. They have no intersection. So the probability of something like that happening would be 0, the chances of it. Okay? Then we've looked already at union, so that's A or B, everything in A or B as it is here. And so to work that out probability-wise, the bits we've looked at so far haven't had any intersection, they've been mutually exclusive. But here, the full definition of it is that it's the probability of something in A plus the probability of it in B minus the bit in the middle. And why is that? We don't want double counting, okay? Double counting. Okay? And then lastly then, so our intersection down here, well, we remember from sets, that's the bit in the middle, the bit that is in both A and in B. And so the probability of the two of them together, well, we work that out, okay? And that, we'd see here, when they're independent, we multiply, similarly to the fundamental principle of counting, we multiply the two probabilities because it's the probability of one thing happening after another, of, okay? Now we're going to take a quick look at an example of working them both together. So here in this question, we're asked, in a survey, students were asked what brand of energy drink they liked. The probability that student liked brand C was 0.6, that they liked brand P was 0.5, and that they liked neither drink was 0.1. So first of all, we see that we have two different brands. Okay, so I draw my my Venn diagram based on that. Now, and so that information there, so beside C, I know that the total for it is 0.6. And beside P, well, the total is 0.5. And that last piece of information just up here says that neither drink, so that's out in outer space as we remember, 0.1. Now the one piece that I haven't put in up here is for my universe, for U. Well, what's U equal to? All our probabilities must add up to 1, okay? So we know here that U must be 1, okay? So obviously we don't know our intersection, so we can call that X, okay? So here then I would have 0.6 minus X, isn't that right, from before? And here I'd have 0.5, take away my X from before. Exact same procedure as when I've worked with Venn diagrams in the past. Okay, so we're just going to tidy that up now. So in order to solve for X, I just simply write as I would have before. So 0.6 minus X plus X plus here my 0.5 minus X plus, well, what do I add onto all of that? I add on my 0.1 from outer space, and again then I know that that is all equal to the total universe, which in this case, in every case, because all my probabilities must add up to 1. So when I add those together, well, I know that minus X and plus X, they cancel. So just tidying up the numbers, 0.6 plus 0.5 plus 0.1, well, that is 0.6, 0.5, 0.1 gives me 1.2. What else am I left with up here? I'm just left with my minus X, and so that is equal to 1, okay? Equals 1. And so just to tidy that up then, I want to obviously get the x on its own, so I'm going to take away 1.2 on this side. So on this side of the equals I must do the same. So 1.2 minus 1.2, they cancel. It just leaves me on this side of the equals with minus x. And then over here, 1 take away 1.2, well that's minus 0.2. Now I know if minus x is equal to minus 0.2, then x must also be equal to 0.2. And there we're solved, we found our x. So here then we can fill in for x, well that's 0.2. I take away my 0.2 here and that gives me 0.4. Over here I take away 0.2 from 0.5 and I'm left with 0.3. And again, just if I check, 0.4 plus 0.2, well that gives me a total of 0.6. Plus 0.3 brings me up to 0.9, and the 0.1 brings me up to 1 whole unit, the whole universe. Okay, so now that I have my Venn diagram complete, I can look at the questions. So here we're asked in part 2, what's the probability that the student liked brand C and brand P? And as we know from our set theory, and means the intersection. So the intersection, well, we can see very clearly the intersection of C and P is 0.2. Here then in part 3 we're asked, what's the probability that students liked brand P only? So P only, well that's the probability of P, and we know that symbol as well means without C. So it's just the right hand side of the Venn diagram with P. So that's straight away we can see it's 0.3 or our 0.5. Take away our intersection, take away our 0.2, which gives us the 0.3. Okay, so as you can see, the probability section that links with set theory is very much the same as everything that we would have done in set theory before. The only thing that we have to remember now is that our probability, our universe, this time, it has a total of 1, because as we know, all our probabilities together can only add up to 1. Or our maximum range on the probability scale is 1. Okay, so that's our big rule, that's the big thing that we need to remember when we're doing these. And so also just very important when we're going doing these, and you can check them out in your Schoology folder as well, but just to make sure that you go back over sets. Okay, so you can start the question now and use this video to guide you through it. Start the question in Schoology in your folder.